One of the things that few people appreciate is that the internet was able to expand so quickly because, well, we already had a network ready to go. And that was our long-distance telephone system. Now, to pass the Network Plus, you really need to understand how the telephone system works. And it's actually kind of cool. So let's take a moment, and we're going to go way back in time. Ever watched any of these old movies where they have the phone on the wall, the telephone's made out of wood, and they're picking it up, and they turn a crank, and they're like, "Hello, Sadie? Yeah, give me Don over at the butcher shop," and all that type of stuff. Well, that is actually how phone systems originated over 100 years ago. So to appreciate that, let's take a look at our blocks here. What would happen in the old days is that you would have telephones installed into individual locations, and then a physical line from each one of those telephones would be brought into a central office. These central offices were usually no more than 3 miles away from any particular phone. The reason for that was that analog signals had a bit of a problem going more than about 3 miles at the voltage they used back over 100 years ago. In the central office was this, usually a lady, that's where Sadie was, and she would hear you as you cranked. You were actually bringing voltage onto the line. She would see a light come on or a buzzer come on. She would connect to you and then make a physical connection between you and whoever you were trying to call. Now this system worked great, and after a while, by World War II, Sadie had disappeared and we had replaced her with electronic systems, but it was still an analog system and it worked well. The challenge we ran into is when you wanted to talk to somebody further away. So if we look at a situation like this, here we have some people connected to one central office and other people connected to another central office. Now, if I wanted to go make a call from here to here, we could do that, but we would use something called trunk lines. Now, trunk lines worked in a very interesting way. What they would do is they would use something called frequency division multiplexing to allow you to handle more than one call. So if you got lots and lots of people calling between these two central offices, what the phone company would do is they would take your phone call and then they would shift the frequency. So all of a sudden your phone call would sound like this. And then somebody else's, I can't even get as high as it would be, but that multiplexer would split through frequency division multiplexing all of the different calls into these different frequencies. It would come over the trunk line, over to the other end, which would bring it back down, and then it would be handled that way. This worked really, really nicely, except for one problem, and that is analog by definition really has a problem with long distance. And I'll bet you've even seen in some of those old movies where the guy's trying to call from New York to let his ma know that he's going to be in Wichita in a week or something, so get ready. And it'd be like they couldn't hear each other, and it was difficult. So what happened is that starting in the 1950s and pretty much completed by the 1970s, in the United States we switched from an analog to a digital system. Now, with a digital system, you're going to see a couple of things change. With a digital system, the conversation between your location and the central office was still analog. But once it got into the central office, it would be broken up into individual digital samples that would be moving along and building up and making the conversation. Once it gets to the other central office, it was sent back to analog. So you would have these little digital pieces that were being sent across. All of these little pieces are being sampled with 8-bit samples 8,000 times per second. So each little piece of this conversation is 64K. Now you would have lots and lots of these going over, so it's not just one, you just keep going and going until the conversation's done. Now the trick part to this is that everybody hears the word 64K in the telephone world, and if you haven't, you're going to be hearing it a lot shortly. So the reason 64K came along was simply because the telephone company thought that that was the proper sampling rate to be able to hear a good phone conversation. And if any of you ever use a landline anymore, you can appreciate that compared to most cell conversations, landlines sound pretty good. Anyway, if we come back down here and take a look, the trunk line is going to change dramatically. Instead of being a frequency division multiplexer, it's going to go into time division. So the conversations are being broken up into these 64K chunks, but that one big line is carrying a lot of different conversations. So we had to take these individual chunks, which are known as a DS0 signal, and we're going to combine them into a great big chunk, which is called a DS1. A DS1 signal is 24 DS0 signals all going down the same piece of wire. Keep in mind that we're not doing frequency division multiplexing anymore, we're doing time division multiplexing. And anybody who's been working in networking, particular Ethernet, understands that we don't have frequency issues, we just have everything in little blocks. So the whole idea of frames and all that was happening back in the 1950s. Okay, so we've got a DS1. Now DS1 is just a signal type, and it runs on a very specific type of cabling system called T1. So if you've got 24 DSOs on a DS1, 24 times 64K comes up to be about 1.5 megabits per second. So in the networking world, we say we have Ethernet frames and Ethernet cable. In the telephone world, we use the term DS1 frames, but it's on a T1 system. Now that's great, but you could even go faster than that. The other type, and these are all copper carriers, by the way. The other type that you can use is called a DS3. A DS3 signal runs 28 DS1s simultaneously, so it is a lot of signaling going on. Now in Europe, we have E1 and E3, which are very, very similar to T1 and T3, but not exactly the same. Make sure you memorize all of this for the Network Plus. Now the thing you need to appreciate about all of these T carriers is that they're point-to-point connections. There's no telephone number associated with them or anything like that. They were originally designed just to interconnect central offices. However, over time we've discovered that these are pretty good ways to haul data as well. Now if you want to get, say, 1.5 megabit per second throughput, you can order yourself a T1 line, and what they'll do is they will literally run a line from their central office to your location. In most cases, there's so many lines already installed, they just pick one of a zillion that are already there. So they run this line, and on each end of that T1 line is what we call a CSU-DSU. By the way, a T1 line, the interconnections look pretty much like just shielded, twisted pairs, so it looks pretty much like Ethernet. So these ends are plugged in, and you have a CSU-DSU. Now, the CSU-DSU acts as the endpoint, and it can be, you can do a lot of stuff with CSU-DSUs. For example, you can plug your CSU-DSU directly into a router. Any good Cisco router knows how to speak T1, no problem. Those are plugged in, and it just runs forever. So once it's turned on, it is a permanent connection, it's always running. Now, there's one other little quickie term I want to throw in, and that is something called a BERT test. Whenever you have a problem with the T1 line, you have a BERT test. It usually manifests itself as a button on the CSU-DSU, and it's a bit error rate test. And it's just a quick and dirty way, if you think you've got a problem with the T1, you do a BERT test on it to make sure that that interconnection is good. Now, also on the Network Plus is the term T1 crossover. A T1 crossover is a pretty weird little thing, and you'll see it a lot of times where people are experimenting with routers. You can take two routers that have a built-in CSU-DSU, and you could literally take one little piece of T1 crossover, plug it into each one of the CSU-DSUs, and it's a fun and quick way, like if people are learning Cisco certifications and such, they can use this as a way to emulate a full-blown T1 connection. So that is on the test, so make sure you're aware of that. So that's the basis of telephone communication and how it affects ourselves in terms of the internet. The big thing I want you to take away from this more than anything else is an appreciation of the difference between frequency division multiplexing versus time division multiplexing, and make sure you know your T connectors. It's on the exam.